Hello everyone. In this video, we will learn about a formula for variance and standard deviation of binomial random variables. Well, recall that when we have a random variable, we find EX, which is mean, and then for variance, what we do is that we find the difference of each value from mu, square it, and then multiply by PDF at that point. X2 minus mu squared times f of x2 and up to xm minus mu squared f of xn. Then the standard deviation of x is just positive square root of the variance. Well, let's do this in an example. A coin is tossed 3 times. Well, this example we have done so many times. Now we know that the values for the number of heads in 3 toss is either 0, 1, 2, or 3. The probability is 1 over 8, 3 over 8, 3 over 8, and 1 over 8. And we know what is mu. Mu is given, this is expected value of binomial random variable 3.5. And this is given by n times p, which is 3 over 2. Now, we want to calculate what is a variance of this random variable. So what we can do, one way to do this is that I will introduce a new column here, x minus mu squared, or x minus 3 over 2. So x is this, minus 3 over 2 squared. X is that, 1 minus 3 over 2 squared. X is that, 2 minus 3 over 2 squared. And 3 minus 3 over 2 squared. So these values, this is now negative 3 over 2, which is 9 over 4. This guy is 1 over 4, negative 1 over 2, square of that is 1 over 4. This guy is 1 over 2, square of that is 1 over 4. And this guy here is 9 over 4. Now, the variance of this random variable is you multiply each one of these entries in that column to the entries in the column for PDF and add them. Okay, so in this case, this is 1 over 8 times 9 over 4 plus 3 over 8 times 1 over 4 plus 1 over 3 over 8 times 1 over 4 and 1 over 8 times 9 over 4. So you see that if I multiply, all of them have the denominator 32 and the numerator 9 plus 3 plus 3 plus 9. Maybe I do a bit of that. So this is 24 over 33. Well, divided by what? By 8. That's a good one. So that will give me 3 over 4. Yeah. And well, we found that the variance of this guy is 3 over 4. Well, the standard deviation in that case is going to be square root of the variance. Well, always it is given by that, but in this case it's root 3 over root 4, which is root 3 over 2. Okay. Well, this was a binomial random variable, and for the binomial random variable, as we learned before, there is a formula for mu. Now we have a formula for variance and standard deviation. So that is a theorem that I'm giving you. So variance of B and P, remember that was NP for mu before, yes? Now you have to multiply it by 1 minus P as well. And the standard deviation is going to be square root of NP1 minus P. Well, and note that for the above example, variance of, basically we're trying to find variance of B3.5, and that is 3 times half times 1 minus half, and that is 3/4. How about standard deviation? This is square root of 3 times half times 1 minus half, that is root 3/4. That in that example we actually did compute by hand, but this formula works always, all the time. Okay, let's go do another example. What is the variance and standard deviation of number of sixes? So here the random variable counts, so x, the random variable, it counts number of sixes. So it means that we have a binomial random variable. How many trials? 4 trials. The chance that we get 6 when we roll a die is 1/6. Okay, there's only one side out of 6 sides of the die to give us number 6. Now, the variance of such a thing, such a random variable, we know how to calculate. 4 times np 1 minus p. And that will give me 36 down there. 4 times 1 times 5. And that is 20/36. But we can simplify, and I can write 5/9. Then that's the variance. Standard deviation of this guy is square root of what we found there. So 4 times 1/6, 1 minus 1/6. You can write 5/. Well, that can be simplified like that. So the upshot is that when it comes to binomial random variable, or the random variable that you're working with, if it is binomial random variable, you do not need to do the table and all those things. You just go ahead and use these formulas, and your life is going to be colorful, easy, nice.